absolute value inequalities. Now we have a variety of answers. So let's look at how this affects things on the number line. X greater than 3, no big deal, right? So X greater than 3. So it could be 4, could be 5, could be 6, no problem. Oh, it's not equal to, so I'm going to put a big open circle, but greater than 3. But wait a second, it said the absolute value of X was greater than 3. So what happens on the negative side? Well, let's see. Would negative 1 work? Negative 1, absolute value of negative 1 is 1 greater than 3? No. What about negative 2? Well, we know, no. What about negative 3? Well, it can't equal that, so that's going to be a big open circle on negative 3. But as soon as I get to negative 4, what happens? Well, the absolute value of negative 4 is positive 4, which is greater than 3. And that's going to keep happening, negative 5 and so on. So look at what we end up with. Oh wait, an absolute value greater than 3, that means we get an OR statement. So let's go ahead and write that. X is less than negative 3 or X is greater than positive 3. Let's remember that as you go along, because when we have absolute value equations with more things in them, we need to break it up like this and set it. Remember, this arrow is how that points. This arrow is how that points. So always think of that number line when you're setting up an absolute value greater than 3 in this case. Then when we go to our absolute value less than or equal to 5, now what's going to happen? Well, of course, we have our 0, and then we have our 5. You probably know something's going to happen with negative 5, right? But what does it look like? Well, can it be 5? Yep, because it's equal to. So I'm going to put a big shaded in circle there. And could it be 6? No. 6 less than or equal to 5? No. 4? All right, so heading this way. Okay, we know that that's going to work. What about negative 2? Absolute value of negative 2 is 2. 2 is less than 5. Sure. What about negative 5? Absolute value of negative 5 less than or equal to 5. Well, yeah, because 5 can be less than or equal to 5. Yep, sure. So I'll put a big close dot there. What about negative 6? Absolute value of negative 6 less than or equal to 5. Well, then that's 6 less than or equal to 5. That's not true. We're done. So it's just right in between. Hey, we've seen this before. It's in between. It's linked. So negative 5 less than or equal to X less than or equal to 5. Less than link. Wow, that's a great way to remember to set these up. And you know from our studies on inequalities, and shades in, so this is an and statement, or shades out. That's an or statement. GreatOR, less than, link. Look at this next inequality. Is it a less than link or is it a GreatOR then out, right? Oh, it's GreatOR then out. So I love just kind of like remember or is an out, and that helps me remember how to set this one up. So I go 20 plus 1/2 x. Oh, and then this arrow is facing that way, so it's less than the negative value, or 20 plus 1/2 x greater than the positive value. So just think of it on that number line. If you're ever kind of thinking, okay, whoa, which way does it go? Oops, I need open, right? So it needs to go that same out. Less than the negative, greater than the positive. Go ahead and solve each inequality because you know how to do that already. So look at that. We get x is less than negative 52 or x is greater than 28. How would that line up on the number line? The right way, right? This way, this way. Perfect. Look at D now. D is a less than. What are we going to do? Less than link. It's an and. It shades in. Less than link. So now think about this setup. How does this setup look on the number line, right? It looks like it's between two values, and it's between the negative, less than or equal, and the positive. So remember why we're setting this one up as a linked inequality, because it's in, and why this one wasn't, because it ends up out. Once again, go ahead and solve this. You know how to do this. How did you do? Okay, the next two are for you to try and really focus on the setup and understanding how to set this up. Let's check your work. See my pink step for both of these? Make sure that yours looks just like that. I made it pink because it's that important that your setup is correct from the beginning. See, less than, so I know that this is an and statement, and is linked, so I write it out linked before I even start solving. This one's GreatOR, so it's an or statement, so I split it up separate and write the word or between my solution. So for this first one, I got -32 divided by 3 is less than x is less than 22 divided by 3. So there's my solution for that one. And then the one next door, x is less than or equal to -12, or x is greater than or equal to 1. So remember, less than linked, so it's an and statement. GreatOR then is or, so it points out. Number 4 is about tolerance. So we have these inequality solutions sitting here already for us. Now look, they're linked statements, so those must be and statements. So they're less thans, which I can kind of see as I look through them. So we're gonna rewrite these as absolute value inequalities. So it's actually kind of what we did up here, but in reverse. So we're starting with the solution and we want to work back to the absolute value inequality. So let's see, we have some questions here to kind of guide our thinking. It says, what's the perfect fit for this inequality here, and what would be acceptable, like still fit in the interval? So I can kind of look at this. 6 is less than or equal to x is less than or equal to 8. Now, what would be like the perfect value for x that's right in the middle of those? Well, 7. So I'm going to call that my target. So my target value would be 7. That would be the value that I'd love to have. But what's acceptable? Well, anything between 6 and 8. So like 6.1 would be acceptable. So we're going to call that our tolerance, or what we would tolerate. So I would accept anything that's within 1 unit of 7. So my tolerance is going to be 1. So let's set up the absolute value inequality. So absolute value of x minus my target value is less than or equal to my tolerance. So here we go. So my target is 7. So absolute value of x minus 7 is less than or equal to 1. Now, if I wanted to check to make sure this was the right absolute value inequality, I could always do what we did up here, where I go ahead and write it as a linked statement and solve through for x. All right, go try that with b. Now remember, you're trying to think about, okay, well, what would be perfect, okay? And then what's acceptable? What's my tolerance? Okay, so my target for this next one would be 8, because 8 is right in the middle of 7.9 and 8.1, but I would tolerate anything that's 0.1 unit away from that. So my absolute value inequality is absolute value of x minus 8 is less than or equal to 0.1. Now this next one, it's not as easy to figure out, okay, well, what's perfect? What's right in the middle of 7.4 and 12? That's a little bit tougher. So we might have to think about it a little bit. So if I want to figure out what's right in the middle of 7.4 and 12, I can just add 12 plus 7.4 and divide by 2. That's going to help me know what's right in the middle. So that's 9.7. So if my target's 9.7, well then how far are 12 and 7.4 from 9.7? So like 12 minus 9.7, that comes out to be 2.3. So I would tolerate anything that's 2.3 units away from that middle 9.7. So my absolute value inequality is x minus 9.7 is less than or equal to 2.3. Let's try to apply this to context now. So if I look here, it says a part for a TV set is intended to be 56.1 millimeters long. They've determined it's acceptable if it's within 0.4 millimeters. So it says write an absolute value equation to model the specific part. Okay, well, we know that the part is intended, so my target length is 56.1 millimeters, and I would tolerate anything within 0.4 millimeters of that. So I would go, okay, x minus my target is 56.1 in my absolute value bars is less than or equal to 0.4. So there is my absolute value inequality. Use inequalities to express the acceptable lengths. Okay, this is a less than statement, so we know it's and linked. So negative 0.4 is less than or equal to x minus 56.1 is less than or equal to positive 0.4. So I'm just gonna solve for x, add my 56.1. So it looks like I get 55.7 is less than or equal to x is less than or equal to 56.5. So that means the acceptable lengths for the TV part are between 55.7 millimeters and 56.5 millimeters. Can't you see how we'd use this in real life? We're not perfect human beings, so we have that little margin of error, so we'd want to have a range of what's acceptable.